A hidden chamber glows with the first light of the solstice, a perfect alignment planned for thousands of years. This is the science behind the alignment of ancient temples and seasonal stars, a story of celestial secrets built into stone. You will discover how our ancestors mastered the cosmos without modern tools, tracking the heavens with such precision that their temples still mark the seasons today. How did cultures across the globe independently unlock these astronomical mysteries, and what profound knowledge did they encode in their architecture? What does it mean to build a doorway to the sky? That sense of order was not a vague hope but a precise science, born from countless nights spent watching the stars. Imagine a world without electric lights, where the night sky was a brilliant, living tapestry. For ancient people, this was their reality and their library. They noticed that the sun did not rise and set in the same place every day. Over the course of a year, it traveled along the horizon, moving north and south. The 2 points where it stopped and reversed direction became the solstices, the longest and shortest days. Similarly, they tracked the moon's complex cycle and the steady, predictable positions of certain stars. These were not just points of light, they were a cosmic clock. The appearance of a specific star cluster just before dawn might signal the arrival of spring rains, a vital cue for planting crops. The movement of another star could mark the time for a harvest or a seasonal migration. This celestial calendar was a matter of survival, dictating the rhythm of life itself. So it is no wonder that this profound relationship with the heavens became central to their spiritual world. The sky was the domain of gods, and the predictable movements of celestial bodies were seen as the divine will made visible. By building structures that aligned with these cosmic events, our ancestors were creating a permanent link between their world and the realm of the gods. A temple doorway that caught the first ray of the solstice sun was not just an architectural feat, it was a sacred conduit. This universal impulse to bridge earth and sky is why we find these aligned structures from the deserts of Egypt to the jungles of Central America, each one a testament to a shared human quest for meaning in the stars. But how do you build a doorway for a god without even a simple compass? The answer lies in a suite of ingenious tools born from relentless observation. Long before the telescope, ancient astronomers developed their own precision instruments. The most basic was the gnomon, a simple pole stuck upright in the ground. By meticulously tracking the length and direction of its shadow throughout the day and across the seasons, they could pinpoint the solstices and equinoxes with remarkable accuracy. This was the foundational sundial, a device that turned the sun's path into a measurable reality. In Egypt, the quest for perfect alignment led to the Merkit. This instrument consisted of a palm rib with a slit cut in it, used like a gun sight to track the passage of specific stars. A second person would stand at a distance, marking where the star crossed a plumb line. By aligning these sightings, Egyptian astronomers could trace a perfect north-south meridian line, a crucial first step in orienting their monumental pyramids. On the other side of the world, in India, the Yasti Yantra served a similar purpose. It was essentially a giant pillar used to measure the sun's altitude, allowing for precise calculations of time and celestial position. For large-scale construction, more complex tools were needed. The Greek dioptra was an early theodolite, a sighting tube mounted on a stand that could measure horizontal and vertical angles. The Roman groma was a surveyor's cross used for laying out right angles and straight lines across vast distances, essential for creating the foundations of temples and cities. And to track time through the long, star-filled nights, they used clepsydras or water clocks. These were containers that allowed water to drip at a steady rate, marking the passing hours independent of the sun. These were not just tools, they were extensions of human patience. The data they provided was not collected in a single lifetime, but was painstakingly gathered and refined over generations. It was this accumulated, cross-generational knowledge that allowed a master builder to confidently lay the first stone of a temple, knowing that in 100 years, on a specific morning, the rising sun would strike the inner sanctum. This marriage of simple technology and profound, long-term observation represents humanity's first great leap into systematic science. It was a science driven by a need to connect the earthly and the divine, turning celestial rhythms into immutable stone. The sun was the most dependable partner in this celestial dance, its path across the sky a reliable guide for life itself. Its annual journey, marked by the solstices and equinoxes, became the foundation for countless temples around the world. These were not random dates, they were the critical turning points of the year, signaling when to plant, when to harvest, and when to hold the most sacred ceremonies. In Ireland, the massive stone tomb of Newgrange captures this relationship with breathtaking precision. Above its entrance, a narrow opening called a roof box acts like a celestial keyhole. For the entire year, the inner chamber remains in deep shadow, but for a brief window of around 17 minutes at dawn on the winter solstice, a slender beam of sunlight streams through this opening. It travels down a long passageway to illuminate the central chamber, a dramatic event that transforms the silent space into a vessel of golden light. This was clearly a deliberate design, a way to symbolically bring the life-giving sun into the realm of remembrance during the year's darkest days. Far across the Atlantic, the Maya engineered their own solar spectacle at Chichen Itza. The pyramid known as El Castillo is a masterpiece of astronomical architecture. During the equinoxes, when day and night are of equal length, the setting sun casts a series of triangular shadows down the balustrades. These interlocking shadows and panels of light create the undulating body of a giant serpent, appearing to slither down from the temple at the summit to connect with a stone serpent head at the base. It is a dynamic, moving sculpture crafted entirely from shadow and light, a powerful representation of the feathered serpent god Kukulkan descending to earth. Similarly, many Egyptian temples were oriented so that the rising sun on significant dates, like the birthday of a pharaoh or a festival, would shine directly down the main axis to illuminate the statue of a god within the inner sanctuary. To achieve these precise alignments, ancient builders needed a deep understanding of the solar year. They had to know its exact length and track the sun's shifting points of sunrise and sunset along the horizon with incredible patience. The sun's unwavering consistency made it the perfect timekeeper, a universal clock that different cultures learned to read and honor in their own unique ways. Through these solar connections, they harmonized their most sacred spaces with the rhythm of the cosmos itself. While the sun offered a steady rhythm, the moon presented a far more complex and mysterious dance. Its path across the sky is not a simple repetition. It wobbles and shifts over a long 18.6-year cycle. Within this cycle are the lunar standstills, moments when the moon reaches its most extreme northern and southern rising points, an event far less frequent and more challenging to predict than a solstice. And yet, ancient builders encoded these subtle lunar patterns into stone with astonishing foresight. At Stonehenge, the great monument is not only a solar calendar. Specific stones and the famous station stones are positioned to frame the horizon where the moon rises during a major standstill. This would have been a rare and powerful event, perhaps marking a pivotal moment in a ceremonial calendar that spanned generations. On the Mediterranean island of Malta, the Mnajdra temple complex captures a different lunar event. Certain corridors and doorways are aligned so that the light of the equinox moonrise, when the full moon rises along the same path as the equinox sun, would have illuminated the sacred spaces within. This dual alignment of sun and moon reveals a sophisticated layering of celestial knowledge. Further west, Mesoamerican astronomers tracked the intricate relationship between the moon and the brilliant planet Venus, weaving their cycles together in a celestial tapestry that guided the timing of rituals and the orientation of their pyramids. To achieve this, these cultures had to commit to observations that stretched far beyond a single human lifetime. The moon's orbit slowly rotates relative to the stars, meaning that a complete understanding of its full cycle required patient, cross-generational record-keeping. This was not a casual hobby, it was a long-term scientific project. The effort invested in these lunar alignments speaks to a profound desire to comprehend the entire cosmos, not just its most obvious player. The moon, with its changing face and mysterious motions, was deeply woven into myths and spiritual beliefs, governing concepts of time, fertility, and the unseen world. By building temples that captured its most elusive light, our ancestors were not just tracking time, they were communing with a celestial mystery. But beyond the wandering sun and the complex moon, the fixed stars offered an even grander timescale. These distant, unwavering points of light became the most reliable long-term markers for ancient cultures. While the sun marked the year and the moon the month, specific stars could signal the turning of entire seasons with impeccable timing. In ancient Egypt, the star Sirius held a place of supreme importance. Its heliacal rising, its first brief appearance in the dawn sky just before the sun, was an event awaited with great anticipation. This celestial signal consistently coincided with the annual, life-giving flooding of the Nile River. The floodwaters deposited rich, new silt across the farmlands, ensuring a bountiful harvest. This was not just a coincidence, it was a cosmic promise. Egyptian temples were carefully aligned so that the light of the rising Sirius would shine directly down their sacred axes, a tangible link between the celestial herald and the terrestrial blessing it foretold. Across the world, the tight cluster of stars known as the Pleiades served a similar purpose. For the ancient Greeks, its rising marked the beginning of the sailing season, while its setting signaled the start of autumn storms. Many Native American cultures also watched this cluster intently, timing their harvests and ceremonial cycles by its position in the night sky. Building a temple to align with a star, however, required a different kind of foresight than aligning with the sun. Solar alignments are tied to the horizon, and while they shift very slowly over centuries due to a wobble in Earth's axis called precession, the change is minimal within a few human lifetimes. Stellar alignments, however, are fixed to the slowly drifting backdrop of the stars themselves. For a stellar alignment to remain accurate for centuries, the builders had to possess a deep, almost intuitive understanding of this imperceptibly slow celestial drift. This suggests their astronomical knowledge was not just observational but predictive, built upon foundations of data passed down through countless generations. The precision of these stellar connections reveals a truly astonishing level of long-term planning. It means that when an architect laid the foundation stones for a temple intended to greet the star Sirius, he was building not just for his own people, but for their descendants 1,000 years in the future. This was astronomy on a millennial scale, a sacred contract written in stone and starlight, meant to endure for ages. This subtle wobble in Earth's rotation creates a cosmic clock with a 26,000-year cycle. Known as the Precession of the Equinoxes, this grand cycle slowly shifts the backdrop of stars against which the sun rises on the equinox. The position of the equinox sun creeps backward through the constellations of the zodiac over centuries, a change so slow it is utterly imperceptible within a single human life. To even notice this drift would require meticulous records kept over hundreds of years, a project spanning dozens of generations. Yet, there are compelling hints that some ancient cultures did exactly that. The Great Pyramid of Giza, for instance, is aligned to true north with a precision that seems to account for this very wobble. Its dimensions and the angles of its inner shafts have been interpreted by some researchers as encoding key precessional numbers, a permanent record of this vast astronomical cycle set in millions of tons of stone. Similarly, the foundational principles of Hindu temple architecture are deeply tied to cosmic order, and their alignments may reflect an awareness of this gradual celestial drift, a slow dance of the heavens mirrored in the sacred geometry of their design. What does this mean? It suggests that ancient astronomical knowledge was not merely about planting seasons or marking festivals. Understanding precession reveals a pursuit of pure knowledge for its own sake, a desire to comprehend the universe on its largest possible scale. This was astronomy transformed into a millennial legacy, where observations were faithfully passed down so that future generations could glimpse a pattern far grander than any single harvest or lifetime. It represents the absolute pinnacle of their celestial science, connecting the silent, steadfast stones of their temples to the most majestic and slow-turning cycles of the cosmos itself. A civilization's relationship with the sky was shaped by the land beneath its feet. In the flat, predictable landscape of ancient Egypt, the sun and stars reigned supreme. Their temples aligned with solar events and the star Sirius, directly linking cosmic patterns to the life-giving floods of the Nile. This was a cosmology of cycles and rebirth, mirrored in the rigid, enduring geometry of their stone monuments. Far across the world, in the dense jungles of Mesoamerica, a different celestial dance unfolded. Here, the Maya became master timekeepers, obsessed with the complex cycles of Venus. They tracked its appearances as both the morning and evening star, weaving its movements into their sacred calendars and aligning their pyramids so that the planet's light would strike specific points during key rituals. They also marked the solar zenith, those unique days when the sun passes directly overhead and casts no shadow, a powerful event in the tropical latitudes that signaled the arrival of vital rains. Meanwhile, across the Atlantic, the builders of European megaliths like Stonehenge faced a different challenge. In the cloud-swept, temperate north, the moon's dramatic extremes held more sway than the sun's steady path. Their massive stone circles were often calibrated to capture the moon's most extreme rising and setting points during the long lunar standstill cycle, an event that unfolds over nearly 19 years. This required a different kind of patience, a generational knowledge of a more subtle and prolonged rhythm. And on the vast expanse of the Pacific, Polynesian navigators performed perhaps the most practical alignment of all. They constructed open-air temples called mari, some with stones precisely set to mark the rising and setting points of key navigational stars. For a culture defined by ocean voyaging, this was not just spiritual, it was essential for survival. It turned their sacred sites into permanent nautical charts, etched into the land itself. The beauty of this global phenomenon is not in its uniformity, but in its brilliant diversity. Each culture looked up at the same sky, yet they saw different patterns and priorities, each finding a unique architectural language to bridge their world with the cosmos. This was a universal human impulse, solved in wonderfully local ways. Behind the grand spectacle of light and shadow lay a silent, invisible framework of pure mathematics. The ancient builders were not just master astronomers, they were brilliant geometers and mathematicians. To translate the vast, intangible movements of the cosmos into the fixed, measurable reality of stone, they needed a universal language, and that language was numbers. Long before the Greek philosopher Pythagoras gave his name to the famous theorem about right-angled triangles, the principle was already being used on construction sites along the Nile and in Mesopotamia. The ratio of 3:4:5, which creates a perfect right angle, was a practical secret known to rope stretchers, the ancient surveyors who used knotted cords to lay out the foundations of temples and pyramids with unerring accuracy. This was not abstract theory, it was applied knowledge, a tool for creating perfect squares and alignments on a colossal scale. In classical Greece, this mathematical harmony reached an aesthetic peak with the golden ratio. This special proportion, roughly 1.618 to 1, was found to be inherently pleasing to the human eye. Greek architects deliberately incorporated this ratio into the Parthenon, governing the relationship between its length and height, the spacing of its columns, and even the sculptural details. The building feels so balanced and beautiful because its very structure echoes a mathematical pattern found throughout nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. It was a way of building the order of the natural world directly into a house for the gods. Meanwhile, in India, Vedic mathematics provided a complete spiritual and geometric system for temple construction. The Vastu Shastra texts prescribed every detail of a temple's design, from its overall layout to the smallest carving. The central concept was the Vastu Purusha Mandala, a square grid that represented the cosmic being. This grid was not just a blueprint, it was a symbolic map of the universe, and its geometry was intrinsically linked to astronomical directions and celestial cycles. The temple was conceived as a microcosm, a miniature universe in stone, and its alignment was therefore a mathematical necessity for maintaining cosmic order. This deep integration of numbers, angles, and proportions was what made the long-term precision of these alignments possible. A temple aligned to a star for 1,000 years required a foundation that would not shift, walls that were perfectly perpendicular, and sightlines that were geometrically true. The mathematics provided the stable, earthly anchor for their celestial ambitions. This reveals that the alignment of ancient temples was far more than a ritual gesture. It was the culmination of a scientific process, a seamless fusion of astronomy, geometry, and spiritual belief, where the act of building itself became a form of prayer written in the universal language of mathematics. So how do we separate these ancient celestial blueprints from mere coincidence? This is the domain of archaeoastronomy, a field that merges the trowel of the archaeologist with the star chart of the astronomer. Modern researchers approach these ancient sites with a rigorous toolkit, aiming to reconstruct the original intent behind the stones. The process begins with painstaking fieldwork. Using high-precision theodolites and GPS technology, teams measure the exact orientation of a temple's central axis, the alignment of a specific doorway, or the sightline between distant standing stones. They are capturing the architecture's frozen direction, its permanent gaze toward the horizon. But a measurement is just a number. The real magic happens back in the lab with sophisticated astronomical software. These programs can wind back the cosmic clock, calculating the precise positions of the sun, moon, and stars as they would have appeared from that very spot thousands of years ago. This allows a researcher to see if a doorway framed the rising Sirius in the year 2500 BCE, or if a passage was designed to catch the midwinter sunset. Yet an alignment in the data is not proof of purpose. The central challenge is to distinguish deliberate design from accidental orientation. A temple might face the rising sun simply because its builders liked the morning light. How do we know it was sacred? The answer lies in a deep dive into context. Researchers comb through archaeological reports looking for symbolic carvings of stars or celestial deities on the walls. They study ethnographic records of indigenous knowledge, seeking oral traditions that speak of sky gods or seasonal ceremonies. They examine the architecture itself. Is there a special window, a lone standing stone that acts as a foresight, or an inner chamber that only receives light on one specific day? The most compelling evidence often comes from statistical analysis. If you have one temple aligned to the solstice sun, it could be chance. But if you survey 100 temples in a region and find that a significant number cluster around orientations to the solstices, equinoxes, or key stars, that pattern becomes mathematically difficult to ignore. It points to a shared cultural practice, a collective intentionality. This interdisciplinary approach has upended old assumptions. Sites once seen as simple monuments have revealed hidden layers of astronomical sophistication, their stones speaking a language of celestial cycles we are only now learning to decipher. This evolving methodology acts as a crucial filter, helping to clear away modern speculation and romantic projections, allowing the genuine, encoded wisdom of the ancients to shine through with ever greater clarity. Yet this celestial blueprint was useless without the engineering genius to bring it to life. The vision of a perfect alignment had to survive its translation into millions of pounds of stone. Consider the foundational challenge of establishing true north. Egyptian builders achieved this with elegant simplicity. They would set up a circle of low stones with a central pole. By marking the points where a specific star's rising and setting shadows just kissed the circle's rim, they could bisect the angle to find a perfect north-south line. This initial act of celestial surveying was the crucial first step, the invisible thread that would guide the entire monumental construction. For the Inca, the landscape itself was the instrument. They erected pillars on the hills surrounding Cusco, carefully positioned so that the sun's shadow would fall upon a specific marker at a key time of year, like a solstice. Their architecture often framed natural horizon features, such as mountain notches, that the sun or moon would pass through, integrating the sacred sky with the sacred earth in a single, unified design. This mastery of orientation was matched by an even greater feat, the movement and placement of colossal stones. At Baalbek in Lebanon, builders maneuvered monolithic blocks weighing over 800 tons, a logistical puzzle that would challenge modern engineers. They likely used a system of wooden rollers, levers, and immense earthen ramps, coordinating hundreds of workers in a symphony of coordinated force. At Stonehenge, the massive sarsen stones were dragged over 20 miles, then shaped with stone mauls and fitted together using sophisticated joinery. The uprights were tapered slightly to account for perspective, making them appear perfectly straight, while the lintels were connected using tongue and groove joints that locked them securely in place. How did they ensure such perfect leveling and alignment across these vast distances? The answer lies in surprisingly simple yet brilliant tools. Water-filled trenches became their universal spirit level, providing a perfectly flat horizontal reference over any distance. A plumbob, a weighted string yielding a true vertical, was used in conjunction with sighting rods to guarantee that walls rose straight and true. The construction process itself was often a reflection of cosmic principles. The rhythmic, cyclical labor, the coordinated effort of thousands, mirrored the orderly movements of the heavens they sought to capture. The final, breathtaking result was a structure that did not merely point to the sky, but was fundamentally of the sky, its very fabric woven from celestial observation and earthly perseverance. This union of intellect and muscle turned a grand astronomical idea into an enduring physical reality. The grandest celestial alignments were not merely for spectacle, they were the ticking heart of a community's survival. This sophisticated astronomy was transformed into a practical calendar, guiding the most critical decisions of the year. In the arid desert of southern Egypt, the oldest known astronomical alignment in the world stands as a testament to this need. The stone circle at Nabta Playa, dating back over 7,000 years, was a precise observatory. Its stones were positioned to frame the rising sun on the summer solstice, but also to mark the heliacal rising of the star Sirius. For these early cattle herders, this celestial signal was a matter of life and death. The appearance of Sirius just before dawn told them the vital summer rains were coming to the Sahara, and with them the annual flooding of the distant Nile. This knowledge allowed them to time their migrations to the river, ensuring their herds could drink and graze. Far to the east, ancient Chinese dynasties built observatory temples that tracked the sun's path with equal precision. They developed a lunisolar calendar divided into 24 solar terms, each one marking a specific shift in climate and agricultural activity. A temple alignment might signal the arrival of the light rains, the time to plant rice, or the start of the wheat harvest. This was not a general sense of the seasons, it was a detailed, actionable schedule for food production, encoded directly into architecture. The Maya, in their tropical world, focused on a different solar event, the zenith passage. On these 2 days each year, the sun passes directly overhead at noon, casting no shadows. This event signaled the arrival of the heavy rains, and their pyramids were aligned to mark this crucial division of the year into dry and wet seasons, dictating the entire agricultural cycle. The profound achievement of these systems was their reliability. A farmer did not need to understand the complex astronomy behind the temple's design. He only needed to see the sunlight strike a specific stone or illuminate a hidden chamber to know, with certainty, that it was time to plow the fields or gather the harvest. This transformation of abstract cosmic knowledge into a dependable, community-wide tool elevated astronomy from a ceremonial practice to a pillar of civilization. It wove the predictable rhythms of the heavens directly into the uncertain challenge of feeding a people, turning starlight into sustenance. Yet these stone alignments were never just practical instruments. They were chapters in a living storybook built to make cosmic myths tangible. In Egypt, the Grand Temple of Karnak was not merely oriented to the winter solstice sun by chance. This alignment reenacted a sacred drama. The sun god Ra was believed to travel through the underworld each night, facing immense challenges before being reborn at dawn. The first ray of the solstice sun, penetrating the temple's long, dark hall to illuminate the inner sanctuary, was seen as his triumphant rebirth. It was a moment when the myth became real, witnessed by the community, and affirming the pharaoh's divine role in maintaining this cosmic order. Across the Mediterranean, Greek temples were similarly woven into the fabric of their mythology. The Parthenon, dedicated to the goddess Athena, was positioned with its entrance facing the east. At certain times, the rising Pleiades star cluster would be visible directly above the temple. In Greek myth, the Pleiades were the seven sisters, companions to Artemis, and their appearance was linked to the sailing season and agricultural cycles. By framing this celestial event, the temple connected the city's patron goddess to the rhythms of the heavens and the stories that gave their world meaning. This symbolic layer reached its most intricate form in the Hindu temples of India. Here, the entire structure was conceived as a Vastu Purusha mandala, a symbolic diagram of the cosmic being. The temple was not a building that housed a god, it was the body of the god itself, a microcosm of the entire universe. Its precise alignment to the cardinal directions was not just for astronomical observation, it was a spiritual necessity. The central tower, or Shikara, represented the mythical Mount Meru, the axis of the world, and the process of moving toward the inner sanctum mirrored a soul's journey toward enlightenment. Every measurement, every proportion, and every alignment was a verse from the Vedic texts made solid. This integration of story and stone transformed these sites from simple observatories into multidimensional experiences. A farmer witnessing the solstice light at Karnak was not just checking a calendar, he was participating in the rebirth of a god. A sailor seeing the Pleiades rise over the Parthenon was reminded of both a mythic story and the practical start of his voyage. The architecture made abstract beliefs physically manifest, allowing people to walk through their cosmology and touch the stories that define their place in the cosmos. The true genius of these alignments lies in this seamless fusion, where the cold precision of astronomy was warmed by the fire of human narrative. Yet for centuries, many of these celestial conversations fell silent. The precise alignments of countless temples were forgotten, their stone pages left unread as cultures changed and knowledge was lost. The great solar alignment at Abu Simbel in Egypt was one such silenced wonder. For over 3,000 years, the sun's rays reached the inner sanctum to illuminate statues of the gods. But when the construction of the Aswan High Dam threatened to submerge the temple permanently beneath the new Lake Nasser, an unprecedented international rescue mission was launched. Engineers and workers from around the world collaborated to cut the entire temple complex into massive blocks, carefully moving them to higher ground. The most critical task was to reconstruct the monument so that the solar alignment was preserved. A single error of a fraction of a degree would have broken the ancient ritual, turning a divine event into mere coincidence. The successful relocation was a triumph, proving that the preservation of this celestial engineering was as vital as saving the stones themselves. Similarly, the famous serpent of shadow slithering down the pyramid at Chichen Itza went entirely unrecorded by early archaeologists. It was not until the early 20th century that observers, combining local knowledge with renewed interest in Maya astronomy, witnessed and documented the equinox phenomenon. This was not a new construction, it was a rediscovery, an ancient light show waiting patiently in the stones for its audience to return. These rediscoveries continue today, as researchers armed with laser scanners and satellite data find new alignments in sites long thought to be fully understood. Yet this work faces modern obstacles far different from those the ancients faced. Rampant light pollution from cities now bleaches the night sky, dimming the very stars that ancient priests used as their guide. The delicate appearance of Sirius on the horizon, once a brilliant herald, can be lost in an orange atmospheric glow. Urban sprawl threatens the pristine sightlines to the horizon, where a new apartment building or a single telephone pole can permanently block the solstice sunrise from reaching its intended target. Preservation efforts are now evolving to protect not just the physical structures, but the celestial relationships they were built to embody. This means creating protected visual corridors and advocating for dark sky preserves around these ancient observatories. We are learning that the true monument is not just the temple, but the alignment itself, a fragile connection between earth and sky that requires its own kind of care. Each alignment recovered from the dust of history adds another verse to the long story of human curiosity, reminding us that these stones still have secrets to share. The dry Egyptian air still holds the precise intentions of its ancient architects, a civilization ruled by the sun and the stars left behind a legacy in stone, where every temple alignment was a deliberate act of cosmic harmony. The great temple of Amun-Ra at Karnak stands as a masterwork of this principle. Its main axis is oriented so that on the dawn of the winter solstice, the rising sun would flood the entire length of the darkened hypostyle hall, its light reaching deep into the inner sanctuary. This was not a solitary event. A smaller, complementary temple within the same vast complex was aligned to capture the summer solstice sunrise, creating a balanced pair of solar observations that framed the entire year. The entire Karnak complex becomes a sprawling stone calendar, its alignments marking the sun's journey from its weakest to its strongest point. This solar connection was replicated with breathtaking drama at Abu Simbel. Here, the temple was carved directly into a cliff face, and its interior was designed so that twice a year, the rays of the rising sun would travel over 60 meters through the mountain to illuminate statues of the gods Ptah, Amun-Ra, and Ramses himself seated in the sacred inner chamber. The fourth statue of the underworld god Ptah was deliberately left in shadow, a subtle detail proving the precision of the astronomical and theological design. But perhaps the most famous feat of alignment is found at the Giza Plateau. The Great Pyramid is oriented to the cardinal directions with an error of less than 1/15 of a single degree. Its sides run almost perfectly north-south and east-west, an achievement that would be remarkable even with modern tools. Furthermore, its narrow air shafts were precisely angled to point toward specific stars, like the Northern Pole Star and the Belt of Orion, which were deeply connected to the pharaoh's journey to the afterlife. This consistent, millennial-long tradition of celestial alignment served a profound political and spiritual purpose. It visually reinforced the pharaoh's divine role as the sole intermediary between the people and the gods. By controlling architecture that literally harnessed the power of the sun and stars, the ruler demonstrated an ability to maintain Mot, the fundamental order of the universe. The unwavering consistency of these alignments across dynasties reveals a sustained, institutionalized scientific tradition, a celestial knowledge so essential it became the bedrock of the state itself. Mesoamerican astronomers achieved a level of celestial precision that still inspires wonder. Their cities were not just collections of buildings but vast stone calendars, with temple alignments reflecting an obsession with cosmic cycles, particularly the dance of the planet Venus. At Chichen Itza, the unique circular tower known as the Caracol stands as a testament to this focus. Its narrow, slitted windows are not randomly placed. They are precisely aligned to frame the extreme northern and southern setting points of Venus on the horizon. This was not a temple for mass gatherings, but a specialized observatory where priests could track the planet's complex 8-year cycle, a cycle they associated with war and the feathered serpent god Kukulkan. The very architecture was a scientific instrument, its stone gaze fixed on the movements of a single, brilliant point of light. Further north, at the immense city of Teotihuacan, astronomy was woven into the urban fabric itself. The entire city grid, including the massive Pyramid of the Sun, is offset from true north by 15.5 degrees. This deliberate orientation aligns the main avenue so that it points directly to the setting sun on a key date in the agricultural calendar, while also corresponding to the rising of the Pleiades star cluster, an event that signaled the beginning of the rainy season. This was astronomy on a civic scale, an entire metropolis oriented to the heavens. This knowledge was meticulously recorded in Mayan codices, bark paper books filled with complex tables. The Dresden Codex contains detailed Venus tables that allowed priests to predict the planet's appearances as the morning and evening star with an accuracy of 1 day in 500 years. This predictive power was physically manifested in their architecture, with rulers timing their coronations and military campaigns to coincide with specific celestial events, believing they were harnessing the power of the gods. The mathematical system that underpinned this astronomy, featuring the concept of zero and a base 20 numbering system, was as sophisticated as anything developed in the ancient world. These structures were not passive monuments. They were the beating heart of a society that saw no separation between the cosmos and the kingdom, between the movement of a planet and the fate of its people. Across the windswept plains and rolling hills of ancient Europe, a different kind of celestial science was taking root in stone. The great megalithic monuments that dot the landscape are far more than ritual spaces. They are sophisticated astronomical machines built for tracking the sky's most subtle rhythms. Stonehenge stands as the ultimate testament to this evolving knowledge. Its construction unfolded in distinct phases over more than 1,000 years, and with each new arrangement of stones, its purpose as an observatory deepened. The famous heel stone acts as a perfect foresight for an observer standing at the center of the circle, marking the precise point where the summer solstice sun crests the horizon. But the monument's gaze extends beyond the sun. The quieter, more patient alignment is with the moon. Specific stones, known as the station stones, are positioned to frame the horizon points where the moon rises and sets during its major standstill, an event that occurs only once every 18.6 years. This reveals a culture not merely celebrating the sun, but meticulously mapping the entire celestial dance. This long-term vision is even more ancient at Ireland's Newgrange. A massive circular mound older than the pyramids, Newgrange contains a narrow roof box above its entrance. For 5 days around the winter solstice, a single beam of sunlight pierces this opening, traveling down a long passage to illuminate the central burial chamber in a dramatic display of light conquering darkness. The communal effort required for these projects is almost beyond comprehension. Quarrying 80-ton sarsen stones, transporting them over 20 miles, and then raising them into position was a generational undertaking. This means the architectural plan and the celestial knowledge it encoded had to be preserved and transmitted flawlessly from grandparents to grandchildren, a chain of learning unbroken for centuries. The sheer precision of these alignments, achieved without writing or metal tools, fundamentally challenges our modern assumptions about prehistoric societies. They were not primitive, they were pioneering astronomers who inscribed their understanding of cosmic order onto the very land they called home. That silent conversation between stone and sky leaves behind a tangible trail of evidence. To hear it, we must learn to read the artifacts and inscriptions these cultures left behind, separating their actual astronomical intentions from our own modern assumptions. A perfect example is the Nebra sky disk discovered in Germany. This Bronze Age artifact is the oldest known concrete depiction of the cosmos, a bronze disk inlaid with gold symbols that clearly represent the sun, the moon, and a cluster of stars identified as the Pleiades. It is a portable observatory, a physical map of the heavens that proves these communities were systematically recording what they saw. Far more explicit are the inscriptions carved into temple walls. Egyptian hieroglyphs at Dendera detail the observation of planets and stars, while Mayan stelae and codices contain precise tables predicting the movements of Venus with an accuracy that startles modern astronomers. These are not vague mythological references, they are technical records. The architecture itself provides the most compelling testimony. The precise orientation of a temple's main axis is the first clue, but the real proof often lies in the finer details. A single, strategically placed window in a Mayan observatory that frames only the northernmost setting of Venus, or a specific notch in a stone corridor at Newgrange that allows the solstice sun to penetrate for just a few minutes, these are the hallmarks of deliberate design. Researchers face the constant challenge of coincidence. Does a temple face east simply because it is a pleasant orientation, or is it a sacred alignment with the equinox sun? The answer emerges through statistical analysis. When you survey dozens of temples across a culture and find an overwhelming pattern of alignment to specific celestial events, the probability of chance evaporates. The evidence must be woven together, the artifact with the inscription with the architectural feature, creating a strong cord of proof. This careful, evidence-based approach constantly corrects our understanding. Grand theories about ancient astronauts or lost super-sciences often crumble under this scrutiny, while the true, and perhaps even more impressive, picture of human ingenuity comes into sharper focus. Each new discovery, from a carved symbol to a precisely angled foundation stone, adds another piece to the puzzle, steadily revealing the profound and practical relationship our ancestors maintained with the cosmos. These stone compasses did more than mark time, they guided journeys across the trackless sea. For cultures whose world was the ocean, a temple's alignment was not merely symbolic, it was a vital instrument of navigation. The Polynesian voyagers who settled the vast Pacific were masters of this art. They constructed open-air temples known as heiau, some with stones precisely aligned to the rising and setting points of key navigational stars. A star like Hokulea, which we know as Arcturus, would rise directly over a specific stone pillar, giving a sailor a fixed bearing to steer by. This transformed a sacred site into a permanent nautical chart, its alignments a trusted reference point memorized by generations of navigators before they embarked on voyages of thousands of miles. Across the world, the Phoenicians, the legendary traders of the Mediterranean, likely employed a similar logic. Their coastal temples and sanctuaries, often perched on prominent headlands, may have been aligned with stars like the North Star or the constellation Ursa Major. For a sailor departing from a familiar harbor, seeing a temple's silhouette perfectly framed against a specific star on the horizon would provide a crucial confirmation of their course. This was a seamless fusion of faith and function. The same structure that honored the gods of the sea and wind also housed the practical knowledge to traverse their domains safely. The knowledge encoded in these alignments enabled more than just survival. It fueled an era of incredible exploration and cultural exchange. It allowed the Polynesians to discover and settle islands scattered across an ocean larger than all the continents combined, and it enabled the Phoenicians to establish trade networks that connected the disparate civilizations of the ancient world. This practical application reveals a profound truth. Ancient astronomy was not an isolated, priestly science. It was the engine of connection, a shared language of the stars that guided humanity as we reached across the waters to find one another. These precise alignments could never have been achieved without a dedicated class of knowledge keepers. Behind every stone set to capture the solstice sun was a priest astronomer, a figure who seamlessly blended the roles of scientist and spiritual leader. In the temple complexes of Babylon, these individuals sat in high towers, scanning the night sky for generations. They did not merely watch the stars, they recorded every movement on clay tablets, creating a vast archive of celestial data. Their patient observations over centuries allowed them to recognize a profound pattern, the Saros cycle. This 18-year rhythm governs the repetition of solar and lunar eclipses, and by understanding it, the Babylonian astronomers could predict these awe-inspiring events with remarkable accuracy. Their work was both a scientific triumph and a demonstration of divine order, a way to show that even the most dramatic celestial phenomena followed a predictable mathematical law. Along the Nile, the lector priests of Egypt held similar authority. These were the master mathematicians, the human computers of their age. Using knotted cords and sighting instruments, they performed the complex calculations needed to orient a temple so that its axis would remain true for 1,000 years. Their knowledge was considered sacred, a powerful magic that could literally align the human world with the cosmos. Far across the ocean, the Mayan astronomer priests developed this synthesis to an incredible degree. They created multiple interlocking calendars that tracked the solar year, the sacred 260-day cycle, and the complex dance of Venus. Their ability to predict the planet's appearances as the morning or evening star was not just an astronomical feat, it was a form of statecraft used to schedule coronations, rituals, and even military campaigns in harmony with the heavens. These individuals were the vital link, the living repositories of knowledge that was too precious to be lost. They preserved this wisdom through rigorous oral traditions and, where it existed, through written records in hieroglyphs or codices. Their specialized training, often beginning in childhood, was what made the long-term precision of these temples possible. A master builder might lay the foundation, but it was the priest astronomer who provided the celestial blueprint, ensuring that a doorway built today would still frame the rising star Sirius a millennium later. This deep integration of roles reveals a fundamental truth about the ancient world. The modern idea of a rigid wall between science and religion simply did not exist. For these cultures, observing the cosmos was a spiritual act, and mathematics was the language the gods used to write the universe. The priest astronomer did not see a conflict between measuring a star's path and understanding a deity's will, for they were one and the same profound mystery. Reconstructing these celestial conversations is a delicate forensic science. The first major hurdle is the slow, relentless hand of time itself, which has often altered the very structures we seek to understand. Many ancient temples were not static monuments but living sites, rebuilt and expanded by successive rulers over centuries. A doorway perfectly aligned by one pharaoh might have been shifted by a later renovation, its original orientation now lost beneath newer stones. Natural disasters have taken their toll as well, with earthquakes subtly tilting foundations or toppling keystones that once framed a star's rising point. Even the gentle settling of the ground over millennia can throw off a precise alignment by a critical fraction of a degree, enough to turn a deliberate solar marker into a simple architectural feature. This means that before any astronomical analysis can begin, archaeologists must first perform a kind of architectural detective work, peeling back the layers of history to determine the original form and position of the building. They search for the oldest foundations, the first phase of construction, hoping to find the pristine blueprint as the first architect intended it. Beyond the physical structure lies the even greater challenge of precession, the grand wobble in Earth's rotation. This imperceptibly slow drift means the entire starfield has gradually shifted over the ages. A temple corridor built to frame the bright star Sirius 5,000 years ago would now point to an empty patch of sky, the star having migrated due to this cosmic cycle. An alignment that functioned perfectly for 1,000 years may have slowly fallen out of sync, its celestial target moving beyond the stone window. Researchers must therefore use sophisticated software to rewind the sky, calculating exactly where stars would have been when the temple was new, a process that requires pinpoint accuracy in both the site's dating and its original measurements. Perhaps the most profound obstacle is the silence of the written record. For cultures like the Maya, who left detailed astronomical codices, we have direct evidence of their intent. But for the builders of Stonehenge or the Maltese temples, who left no written language, we are left to interpret their motives solely from the stones. Is a cluster of temple alignments to the summer solstice sun proof of a shared cultural practice, or could it simply be a common and practical building orientation? The key to answering this lies in statistical significance. If you find that 90% of temples in a region face the solstice sunrise, that is a powerful pattern difficult to attribute to chance. Modern researchers combine this statistical analysis with every available clue, from ethnographic studies of descendant communities to the symbolic carvings on the temple walls themselves. A sun symbol carved above a solstice-aligned doorway offers a compelling whisper of intent. This painstaking, interdisciplinary work is a constant exercise in humility, reminding us that we are listening for a faint, ancient signal through the static of centuries, piecing together a forgotten science one careful observation at a time. But how do we move from intriguing possibility to confirmed fact? The answer lies in the powerful fusion of modern science and ancient stone. Today, researchers wield tools those original builders could never have conceived, yet these technologies consistently affirm the astonishing precision of the old ways. Satellite imagery and ground-penetrating radar map entire ceremonial complexes from above, revealing hidden alignments and geometric patterns invisible from the ground. Laser scanners then capture every surface of a temple in 3 dimensions, creating a digital model so precise it can detect subtle shifts in orientation caused by millennia of settling Earth. These hyper-accurate measurements provide the raw data, the frozen coordinates of the architecture's gaze. But a measurement is just a number. The real test happens when scientists feed this data into sophisticated astronomical software. These programs can wind back the cosmic clock with incredible accuracy, recreating the exact sky that would have been visible from that specific spot thousands of years ago. They can calculate if a narrow corridor truly framed the star Sirius in the year 2500 BCE, or if a key notch in a wall was designed to catch the first sliver of the equinox moon. This digital time travel allows for the rigorous testing of alignment hypotheses, transforming a hunch into a verifiable event. Yet, even a perfect alignment in the simulation could still be a coincidence. This is where statistical analysis enters the picture. If one temple faces the solstice sunrise, it might be luck. But if a survey of 50 temples in a region shows that 80% of them cluster around orientations to key solar, lunar, or stellar events, the probability that this happened by random chance becomes mathematically minuscule. This statistical backbone turns patterns into proof. To anchor these alignments in time, scientists rely on radiocarbon dating. By analyzing organic materials like charcoal or bone found in the foundational layers of a temple, they can establish a firm construction date. This timeline allows them to correlate the building's creation with a specific celestial event, such as a rare lunar standstill or the passing of a comet, that might have inspired its unique orientation. This multi-pronged approach has a clarifying effect. It has confirmed many long-held theories, like the intentional solar and lunar alignments at Stonehenge. But it has also disproven others, gently clearing away modern romantic projections to reveal the genuine and often equally impressive intentions of the ancients. This ongoing convergence of trowel and telescope, of statistical models and sacred geometry, continues to refine our understanding. It confirms that what we are witnessing is not a series of happy accidents, but the legacy of a deliberate and profound celestial science. These celestial blueprints fundamentally reshape our understanding of human history. The precise alignments etched into stone across the globe are not monuments to superstition, but to a sophisticated, worldwide scientific tradition. This realization carries profound educational weight, challenging the outdated notion that rigorous astronomy began only with the telescope in Renaissance Europe. When we study how the Maya predicted the cycles of Venus or how Babylonian priests tracked eclipses, we are acknowledging a global heritage of discovery. It corrects a narrow, Eurocentric narrative by showcasing the brilliant intellectual achievements of cultures from every continent, each arriving at profound truths through patient observation and meticulous record-keeping. This is not just about ancient history, it is about redefining the very story of science itself, recognizing that the quest to understand the cosmos is a shared human endeavor. Modern educational programs are now bringing this legacy to life. Students can step into the role of an ancient astronomer, using simple gnomons to track the sun's shadow or sighting tubes to measure a star's path, just as their ancestors did. These hands-on experiments teach the fundamentals of astronomy through the lens of cultural history, making abstract concepts tangible. They learn that science is not confined to a laboratory, but can be born from a deep, spiritual relationship with the natural world. For many indigenous communities, this work is more than academic. It is an act of cultural reclamation. Preserving the knowledge that a certain temple doorway frames the solstice sunrise helps maintain a living connection to their ancestors and their traditional worldview. It ensures that this ancient wisdom is not locked away in textbooks but remains a vibrant, accessible part of our collective heritage. The true significance of these alignments, therefore, stretches far beyond the movements of planets and stars. They stand as permanent reminders of human curiosity and ingenuity, offering timeless lessons in observation, patience, and our enduring place within a vast, ordered cosmos. The silent stones still hold secrets we are only beginning to decipher. Future discoveries in this field will not come from a single brilliant insight, but from the powerful fusion of new technologies and ancient wisdom. Imagine LiDAR scanners mounted on aircraft, piercing the dense canopy of a jungle to reveal the ghostly outlines of a lost city below. These laser maps are uncovering entire temple complexes swallowed by vegetation, and each new foundation stone offers a fresh opportunity to measure its alignment, to see if its builders were gazing at the sun, the moon, or a distant star. Once these structures are found, advanced astronomical software takes over. This digital time travel is becoming so precise it can recreate the atmospheric conditions of a solstice morning 4,000 years ago, calculating exactly how the light would have fallen through a specific doorway. This could reveal subtle alignments that have gone completely unnoticed, patterns too complex for the human eye to detect across the gulf of centuries. But technology alone cannot tell us why an alignment mattered. For that, researchers are increasingly turning to a vital source, the living knowledge of indigenous communities. Elders and cultural practitioners hold oral histories and traditional understandings that can transform a cold, geometric measurement into a meaningful story. A corridor aligned with the winter solstice sun is one thing, but knowing it was seen as the path for an ancestral spirit gives that alignment its true power. This collaboration ensures that the interpretation of these sites is not just technically accurate, but culturally respectful and profoundly richer. On an even larger scale, scientists are beginning to apply machine learning to vast datasets of temple orientations from around the world. These algorithms can sift through thousands of measurements, searching for subtle, global patterns that a single researcher might never spot. Perhaps temples built in a certain era, regardless of their culture, consistently favored alignments with the star Sirius. Or maybe there is a hidden connection between lunar cycles and the orientation of tombs across continents. These emerging tools promise to uncover a hidden layer of celestial conversation, a global language of the stars written in stone. The journey to understand our ancestors' relationship with the cosmos is far from over. With every new tool and every shared story, we peel back another layer, ensuring that the silent dialogue between Earth and sky will continue to speak to us for generations to come. Yet the quest to understand these celestial stones must be tempered with profound respect. Unraveling the alignments of ancient temples is not merely a scientific exercise, it is an endeavor that carries significant ethical weight. At its heart is the need for deep cultural sensitivity. Many of these sites are not abandoned ruins, they remain places of deep spiritual significance for descendant communities. For them, a solstice alignment is not a forgotten astronomical trick. It is a living ceremony, a continuing dialogue with their ancestors. When researchers arrive with their theodolites and software, they must do so as guests, not just as investigators. The most meaningful studies now actively involve community elders and knowledge keepers from the very beginning, ensuring their interpretations and traditional stories are woven into the final understanding. This collaborative approach transforms research from an extraction of data into a shared exploration of heritage. This respect must extend to the physical sites themselves. The very act of investigation can pose a threat. Placing measurement equipment on fragile stonework or increasing foot traffic in a delicate chamber can cause irreversible damage. Every decision must balance the hunger for knowledge with a duty to preserve the monument for future generations. The goal is to listen to the stones without leaving a mark. A parallel challenge is the rise in tourism driven by these celestial discoveries. While public interest is wonderful, the commercialization of an equinox event can overwhelm a sacred space. The serene silence intended for a solstice sunrise can be shattered by crowds, and the very foundations of a temple can be eroded by thousands of footsteps. Managing this interest requires creating sustainable models that educate visitors while protecting the site's physical and spiritual integrity. Furthermore, Western science must humbly acknowledge its limitations. The framework of empiricism and data is just one way of knowing. Indigenous astronomical traditions often encompass myth, spirituality, and a holistic relationship with the natural world that quantitative measurements alone cannot capture. Dismissing our alignment as merely a calendar while ignoring its role in a creation story is to miss its deepest meaning. Responsible research, therefore, embraces multiple ways of knowing, seeing the hard data and the oral tradition as complementary strands of the same profound truth. By centering these ethical considerations, the study of temple alignments evolves into a more meaningful and just practice. It ensures that we are not just decoding ancient blueprints, but honoring a living cultural legacy, protecting fragile sites, and listening with humility to the many voices, past and present, that these stones represent. Our journey through these celestial temples reveals a profound truth, that our ancestors saw no boundary between the science of the sky and the spirit of their world. They transformed silent stone into a living dialogue with the cosmos, capturing solstice sunbeams and the distant gleam of stars to mark the essential rhythms of life. This was not mere stargazing. It was a sophisticated astronomical tradition built on generations of patient observation, a science woven seamlessly into the fabric of faith and survival. The true genius of these alignments lies in their beautiful duality. A pyramid that cast a descending serpent shadow was both a precise solar calendar and a powerful manifestation of a god's descent to earth. A temple doorway illuminated by the rising Sirius signaled the coming floods for the farmer, while simultaneously uniting the community with a celestial deity. These structures serve the practical needs of planting and harvest while nourishing the human soul with myth and meaning. They were multidimensional creations, harmonizing the earthly with the celestial in a single, breathtaking architectural vision. As we continue to decode these ancient blueprints with new technologies and renewed respect, we recover more than forgotten engineering feats. We rediscover a universal human impulse, a shared desire to find our place within a vast, ordered universe. These stones, standing for millennia under the same shifting sky, are our enduring witnesses. They remind us that our own quest for understanding, our own fascination with the stars, is a timeless legacy, connecting us across the centuries to every culture that ever looked up and sought to build a bridge to the heavens.